Hi and Assalamualaikum. My name is Amirul Izzat and my partner is Afi and Ifan. This video is purpose for show you guys about how to use the mesh in Fingerprint SC. Theory of SC, alternating current or SC theory, is concerned with the mathematical analysis of the steady state behavior of the electrical circuit in which the current and voltage vary radically with time. The term AC, or to give it its full description of alternating current, generally refer to a time period waveform, with the most common of all be called sine wave. Sine waves are by far one of the most important type of AC waveform used in electrical engineering. Concept of mesh in AC circuit. Mesh analysis is a result of simplified Kirchhoff law. Recall that according to KVL, the algebraic sum of voltage inside a loop is zero. Consider the following loop. In the loop and for any passive circuit, there are source and sink. However, mesh analysis for both DC and AC circuits are similar. The only difference is that in AC, we are dealing with independence instead of just resistor. The aim of this tutorial is to make mesh analysis for AC circuit simple for you.
Now I want to show you mesh analysis in Fingerprint SC with 2 KVL only. In this circuit, we click the question to find the value of current that going through each branch in the circuit. So I1 and I2. So in this circuit, we have 3 resistor, 1 inductor and 1 capacitor. So we label is this R1 3 ohm, R2 5 ohm, and RT 2 ohm. So this capacitor 1 Faraday and only 1 inductor. So we label it this I1, this I3 and this I2. So we create the shortcut for the ZC that we combine these 3 components. So we label it to Z3. So we label it to into 2 loops, loops 1 and loops 2, because we must apply 2 KVL in this circuit. So for Z1, we got 3 ohm, and then Z2 we use the formula JWL. So we got 2J. And in the Z3, we use the formula 1 per 1 over JWC. So we got the answer 7 negative 0.55 J. So ZL we label as Z2 and ZC we label as Z3. So we apply two KVL in this circuit. That's mean mesh 1 KVL in the loops 1. And then we mesh 2 KVL in the loops 2. So we calculate the mesh 1 KVL. Then we got the equation 1. And then mesh 2 KVL, we apply that, we got the answer. Then we label as the equation 2. For next, we from equation 2, we go through into equation 1. So we calculate directly from equation 2 into equation 1. Then we got the answer for the I1, 2.5 degree 32.3 ampere. So we got the equation 3. From the equation 3, we we combine we into equation 2. So then so we got the answer for the I3. So from this calculation that from equation 2 into equation 1, we got the answer for the I1 IPP point IPP 4.9538 ampere, and then for the I3 we got the answer IPP 1.3883. It's same with the measurement value. So next this is the circuit that we create at the multisim. So in I1 we got the same answer IPP 4.9538 ampere. Then for the I3 we got the answer 1.3883 ampere. So this for the calculation for mesh analysis in single phase AC with 2 KVL.
Assalamualaikum and good evening to Dr. Shafiq. I am Muhammad Irfan bin Laud. Today I will explain about the simulation and conclusion for this assignment. Firstly, we will construct the AC mesh circuit that we have discussed. So to measure the current, we will take the current probe and place to the left of resistor and name as PR1, and place to the right resistor and name as PR2. So to get the current value for AC mesh circuit, we must use the value of IRMS. So we must setting the probe current from instantaneous to periodic. So we must change the both of current probe. After we change the setting, we can run the simulation, and we will from this circuit we will also be able to get the graph. So to get the graph, we must select the split and set to the auto. After that, we can get the graph as on this screen. So we must change the type to X axis because we want to measure the time, and we change because the one is PR1 green line, and the 2 is PR2 blue line. So we do the graph to get the value of delta x. So to get the delta x, we must put the cursor 1 to the 0 value and the cursor 2 0 value current. So we get the delta x. That is phase difference between cursor 1 and cursor 2. We need to find the time of one complete cycle. So firstly, we have the frequency that is 0.3183 from the circuit value, and so we use the frequency formula, get the time 1 divided by f equal to 3.142 seconds. So this value is the one complete cycle value, 3.142 seconds. So we know the value of 3.142 is one complete cycle. So for the delta x, 895
T2 millisecond is equal to X, that is base of the cycle, and we know that 3.142 second is equal to 360 degree, that is one complete cycle. So to get the value of X, we will divide these two value. So after divide, we get the value of base of X is 99.18 degree. So that all for simulation. Conclusion. So the conclusion we can make based on the assignment this time is we can understand about the mesh analysis. We can also know that this mesh is a similar method for AC or DC circuit. The only difference for AC is we dealing with pendant. So we need to change the value. So while measuring the current value, we must take the value of IRMF to get the true answer. After we get the IRMS, we can find out how to get a graph by contrast and AC mesh circuit, and can find out the phase difference PR1 and PR2. Lastly, based on the delta X, we can find the value of cycle for delta X by calculate the frequency that given. Such as that is the only explanation from me for this assignment. Thank you.